Good morning, everyone. Thank you for waking up and being here so early, past breakfast. I'm going to spend some time today in talking about the Log4j incident. So I do have some trouble seeing you, but if you can raise your hand, does anyone here actually handle Log4j during the incident or past incident? Okay, that's a nice 50%. So I'm going to share our experience. I'll give a bit of background about myself and how we approach this, I'll say problem, but how we approach this incident and what we've done with that later. So when we started doing this building this talk, my team and myself, we thought about calling it the Nightmare Before Christmas, because that was basically Log4j. However, we decided to talk more about the roller coaster theme. For me at least, looking back at the Log4j timeline, it was a roller coaster of an event. It started out something small, grew to be something large. We thought we had a cap on it, then we had a new variant, then we had to deploy more patches, then we thought we were on top of it, then we had another variant, then we had to deploy more patches, and it kind of got like a sinus wave. We would do something, we would wait a bit, then we would do something else, we would wait a bit, we would do something else, and the feeling of the emotional roller coaster was just there all the way. So, who am I? My name is Barnhart-Magen. I'm the CTO of an incident response company called Profero. I'm also one of the B-Sides Tel Aviv co-organizers and chairman, and also one of the organizers of the Hackeriot organization. So if you want to chat with me about any of these, please step forward, it'll be fun. I also used to do a lot of public speaking before COVID, so maybe I'll come back to that or not. And I'm also have been to 44Con before, so if you remember my talks from the previous two 44Cons, that was me. Okay, so Log4j, how it all began. As an incident response company, we have a team sitting around the world, and some of our team members sit in New Zealand. And that was Thursday night for them, so we're talking about the New Zealand time frame. And as Brenton, one of our team members, was just going to sleep, some chatter started on Twitter that there's a new hack coming out on Minecraft. And he said, look, guys, this is going to be interesting. There's some interesting thing developing on Twitter. Take a look at it the next morning when you wake up, which was fine. We woke up, and we saw that there's some Twitter discussions about a new hack of Minecraft servers. We didn't see any cyber implications. We didn't connect those dots. And we said, okay, Minecraft, unless you actually have a Minecraft server running on a Raspberry Pi somewhere, nobody really cares. You're either running a very large server and you already did some security, or you're a hobbyist and you don't care about security. So it didn't look important one bit. However, stepping back so I'll be in range. So stepping back, it wasn't fine. By Friday morning, our time, we got the notice about the Minecraft hack being going on. By Friday noon, 4 or 5 hours later, we already saw the first attacks based on Log4j. So POCs sprung up. Actually, they didn't really sprung up immediately because of the vulnerability, but because those POC already existed. This vulnerability was not anything new. It was actually in a talk in Black Hat 3 years ago, or 4 years ago, something like that. It was not a new vulnerability, but somebody found out how to make use of that against Minecraft servers and get RCE, remote code execution, on those Minecraft servers, and he published a tweet about it, and he showed his POC. There were other POCs around, so, everything was on fire. The situation was that this kept happening, so while we do get the feeling that Log4j is gone or has been, that's not the reality. So I collected a couple of snippets just to show you that it still exists and we still see it, and we still saw it months after the incident. So we're talking about Christmas last year, and we still saw months into the new year Log4j related incidents. And I'll even say more than that. This is from 3 days ago, 4 days ago now. So Log4j based attacks still happen. And for me, that's interesting because patching Log4j is a huge monumental engineering task, but it's something that should have been accomplished in the past, I don't know, we're September now, 9 months. That should have been enough time to patch Log4j. But the complexity of the problem, which I'll describe in a moment, actually makes it not as easy to solve as you might think. So as I kind of hinted earlier, it took us a while to connect the dots. So let's talk about day 0. Day 0 for us is Thursday afternoon. Some Twitter thread on Minecraft attacks, but we haven't seen anything cyber-related per se. However, on day 1, by noon of Friday, we already saw coinminers attacks, specifically Xmring, but we saw coinminer attacks on our customer servers. Coinminers attacks are very interesting in that respect, where the way that those attacks work is that all of the infrastructure is usually already prepared ahead of time. So you have the payloads, you have the droppers, you have the CNC, and everything's just waiting for an attack vector to go and take control of some machines. So once a new vulnerability is exposed, they quickly modify it or take advantage of it in order to introduce that threat vector into those machines, and then they have everything else already prepared. So they went from someone on Twitter saying there's a Log4j thing going on, to having control of servers with coin miners running on those servers in about 12 hours. And they probably did it faster than that. We detected it at 12 hours. The way that we discovered that it was actually Log4j related is that we saw a coin miner incident, but we didn't find the attack vector. We didn't see the point of entry. So we started looking at logs. And when we looked at the logs, it really stood out to us that there is a payload that didn't look like it belonged there. And because we saw the payload the day before for Log4j, it's like things clicked. We said, okay, this is actually the payload for Log4j in the coin miner attack. So we knew it was using the Log4j semantics in order to perform their attack vector. As I said, it was not a new exploit. They just took advantage of an existing infrastructure with a new entry, a point of entry, or a new method to take advantage. However, attacks were not limited to coin miners, and as time progressed, we saw attacks shift to other parts of the attack industry. So coin miners were pretty fast, but they're not the only ones. So day 1++, which means the second, third, fifth, 10 days into it, we saw a lot of other types of attacks. We came in to help a new customer. As an incident response company, we either have customers coming into us when they have an issue or when they know they were going to have an issue in the future and want us to help them prepare. So in this case, it was someone actually suffering from a breach. And they knew that the attack was Log4j. And the reason for that, they used our tool, which I'll mention in a moment, and they knew that they were vulnerable to Log4j. So they're already aware that this type of attack is possible, and they're already looking for signs, are they being breached by Log4j or not? But they did not have any type of mitigation against it. So those vendor appliances that they were using did not have patches released by those vendors. So even though everybody was like, having a spotlight on the problem, everybody was aware that Log4j is going to be used by attackers. We had like a 48-hour head start before attacks would begin. Still, there were no patches, and attacks were successful, even though everybody was looking at the logs and seeing those attacks happen. So let me digress for a moment and explain what the hell is Log4j. So a bit of a hand-wavy explanation. If you want to have a deeper explanation, I'll be available after the talk, but hand-wavy thing. Think about logs. Basically, what are logs? These are text messages that have some sort of structure. Sometimes they are well-structured, like JSON-based logs, and sometimes they are not structured at all, where you have like text lines printed out to std out by some application. Log4j, as a Java-based logging library, tries to give additional information or additional inputs to the user of the library. They will identify specific tags or specific tokens in the text, and they will help the user, or whoever is the user of those logs, to get additional information, what we call enrichment. For example, if the log line has the user ID, some integer describing a user ID in the system, the Log4j library will go and replace that user ID with the user name by performing an LDAP query. the end result of it would be logs that make more sense to whoever is managing those logs. So it's a benefit. It's not something bad. And those type of enrichments really help out when you're trying to move from an unstructured set of data into a structured set that makes sense when we're trying to look at the logs and understand what they do. However, as most large-scale systems go, there are complications. For example, think about this pipeline. Maybe if this will work, I'm not sure. No, it doesn't. Okay. So attackers supply some attacker-controlled input into the website. There's some form, there's some API query, whatever, so some input controlled by the attacker. The API captures that and writes it to the log file. The log file itself is not vulnerable. It's a text file. There's nothing vulnerable in it. However, those log files go through another system, the log enrichment system, that will go and try to replace specific sets of data with some external source data, like an LDAP query or a DNS query or something else. However, and to finish the pipeline, after enrichment, it would store that data in something, a database, a data store, an S3 bucket, whatever. The interesting part is that between the block here that says log capture and the block that says log enrichment, hours can pass. In large-scale systems, you write a lot of logs and you collect them in bulk and make operations in bulk. You don't act on each single line in a log. You collect them and work at scale. The ramification of this is that the Log4j library doesn't sit here in log capture. It actually sits in log enrichment. And that means that there is a discrepancy between the time that you see the log coming in over your API, 12:00:00 a.m., versus the time it was actually ingested by the library and the remote code execution was executed, which may be hours later, depending on the way that your pipeline is structured. This is a big hurdle for investigations because there's a disconnect between when you're looking at the event in the log and when actually the incident happens. So it's very tough to tie those two timelines together. So the problem was that, okay, we know that Log4j is the issue. We know it's a software library. Therefore, we need to find the places where we're using Log4j. Sounds easy. It isn't. So I'll try to explain why. Problem statement. We want to find anywhere in our system, in our network, all different machines that are using Log4j in versions that are vulnerable to these types of attacks. Sounds straightforward. However, how would you know if someone is using the Log4j library? This is not like someone using a virtual machine that you spun up in your system. This is a library dependency usually loaded as needed by the Java runtime. So the problem is much more complex than that. You have to find anything running Java on your system, anything running Java that actually calls this library and actually makes use of that library. And you need to do all of that both for your own code, which is easy or relatively easy, but also to any code used by any kind of appliance that you might have on the network where you have no access to the code and usually no access to the processes themselves. Vendors were between, I don't know, slow to extremely slow to respond. So I'll refresh memories. People reached out to the vendors asking them, are you vulnerable to Log4j? And the vendors will go, I don't know, I'll check, I'm not sure. And then people started sharing over GitHub. There were big lists in GitHub about different appliances, I don't know, firewall version, is it vulnerable or not? DPI solution, is it vulnerable or not version. So you would have this huge list in GitHub, and you will go and search for your appliances in GitHub from information shared by the community, is that vulnerable or not, because you were not able to get any answers from the vendors. And I'll touch on that point again in a moment. The last thing that made it so difficult was that, you know, there's the joke that Oracle made at the time, that 3 billion devices run Java. It's actually quite true. A lot of devices run Java. Everything runs Java somewhere. Finding out who runs Java in your environment and which version of Java he's running, and did it not load a Log4j library, that makes it a very difficult problem to solve. So think about the scope of the problem that you need to find. You need to cover any kind of internal or third-party code that you may use. You might not use any Log4j code yourself, but you might be dependent on some library that is dependent on Log4j, or maybe 3 times removed or 4 times removed. Log4j is such a popular library that if you're a developer writing anything in Java, there's over 95% chance that you're going to use Log4j. So let that sink for a moment. Everybody who uses Java uses Log4j. It's like a synonym. Trying to understand what type of appliances that you have, or cloud services that you are using, or even cloud instances that you spun up are using Log4j is also a big problem. They don't come with an SBOM. You have your favorite, I don't know, I'll give an example. Probably it's not true, but I'll just say it as an example. Adobe made an offer to buy Figma for $20 billion. Maybe Figma is using Log4j. Do you have any idea if it's even running on Java? You just have a web API. You have no idea what's happening behind the scenes. It might be vulnerable. You will not know. And in the end, you own your own network. To some degree, you own cloud. To a somewhat less degree, you own your SaaS connections to whatever. And you worry about all of them because all of them may be compromised. So obviously, people were looking for tools. What can they do in order to mitigate this, or even detect this, if not mitigate this, at least be aware of where the problem is? And they opened, they went to, looking for open source solution, which is what most reasonable people will do when they don't get answers from anyone. They will say, I'll take the matter to my own hands and I'll scan my own network, which is fine. So the first open source that we saw on the scene, and this was Saturday morning, so we are now at plus 24 hours, more or less, was a very nice tool. We did an evaluation of it. We did a code review of it to see what exactly does it do. And the algorithm or the concept was pretty straightforward. The binary would send an HTTP packet to a server, to whatever you tell it, IP and port. And in that payload, it would say, Log4j, please resolve this FQDN into an IP address for me. And write the IP address into the log file. Pretty straightforward. Behind the scene, the DNS registrar will be looking for anyone trying to do FQDN resolutions for that specific address, like a canary DNS token. So they would write down into a file saying, someone reached out to me, this is the IP address, this is the name of the host, whatever headers were in the HTTP request. It asked to resolve the DNS request. It asked to resolve this FQDN, and I gave him back this IP address. Therefore, it is vulnerable to Log4j. So, sounds straightforward, sounds good. It might work. It actually does work. So where's the problem? So the first problem was that the DNS was sitting in China. The second problem, probably a bit bigger than the fact that it was sitting in China, was that you basically handed over to some arbitrary entity in China a list of all of your internal vulnerable servers. And when we told that to our customers, they say, oh, no, 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 we're not going to use that tool. And I think that as soon as people realized what that tool is doing, they stopped using that tool as well. But they didn't have any other solution instead. So you still, the only option at the table at that time, at that point on the timeline, was either use some unknown DNS registrar in China to try to understand if you're vulnerable or not, or wait. So we decided that we are going to do something else. So we took a different approach. We thought we are going to write an internal tool based on Nmap, same kind of methodology. Give me a CIDR, a range of IP addresses. I'll scan all of that for the specific ports. I'll try to ping each and every specific port with a payload that asks to call back to my own binary. And if someone opens a TCP socket against my own binary, I'll write it down in a CSV file, and I'll give you an end result saying, these are the list of all of the callback addresses that try to open a TCP socket against my Log4j scanner. Sounds good? It wasn't. So the problem was that we found out that inside the network, there are a lot of other items scanning the network, and we would see like random TCP connections being made even when we are not scanning anything. So we knew we didn't give a 100% correct answer. There are lots of noise that we had to clear out somehow. So we released the first version of the tool on Sunday. Sorry. First version of the tool on Sunday. And on Tuesday, I think morning or lunch, something like that, we released the second version. The second version was a bit more complex. We actually implemented a neutered LDAP server So just the first part of the LDAP handshake in the binary. So the binary would send payloads to whatever IP address it was scanning. The payload would have a request for a Log4j library to do an LDAP resolution to a specific user ID. Our binary was also an LDAP server. It would get a callback from whatever server was vulnerable to Log4j, trying to do an LDAP query. We didn't actually implement LDAP, we just took the handshake, and we wrote down the name and the IP address and the port of the server trying to do this. So now we have a full 100% foolproof way to know that a specific server was actually vulnerable to Log4j. Because we were not actually an LDAP server, no one was actually reaching out to us to do an LDAP handshake unless it came from a Log4j vulnerable library. The benefit that we had was that everything was running locally. So we wrote everything in Go. It was course compiled for Linux and for Windows and for Mac, even Chromebooks. And you could run everything locally on your machine, on your network. You can also run it in parallel when you have huge scopes, when you have a lot of IP addresses. And each one would get a specific subnet and scan the entire subnet. And we did like /16 addresses in like 2 hours. So it was very efficient for our customers to use that. And again, for others, we released that as an open source. So just to showcase kind of what it looked like, we gave as an input a range of IP addresses and ports. It will try to reach out to those addresses. For each address that actually answered the HTTP request, we would send a payload. So first step, HTTP handshake. Second step, Log4j payload. Third step, wait patiently until someone calls you back. Notice that there is a problem here. The moment that I send the HTTP payload to be written into the log file, I get back a status 200. It means that the HTTP connection is over. But the callback might come back in 30 seconds. It might come back in 3 hours. So the part of the system that needs to listen for any incoming callback is disconnected from the part of the system that needs to send out requests. So that is something to keep in mind whenever you're trying to scan for Log4j, because systems might be disconnected exactly because of that pipeline issue that I described earlier. So I'll skip it. Real example. We ran a scanning on a customer's network, and we got back answers from an IP address that belonged to some vendor appliance. Think about that. You have a data center. Some people still have on-premise data centers, probably quite a few of them. And they bought an appliance, plugged it into the wall, and we scanned it and enriched it through the network. And when we scanned it, we got a callback. So we know that it's vulnerable. So it's not a guess. It's not like we think it might be vulnerable to some version of Log4j. No, it's specifically vulnerable to Log4j. Here is the payload. Here is the response. We know it's vulnerable. It's a true positive. So the customer reached out to the vendor, and the vendor went silent. So we contacted the vendor and said, look, I don't know why you're dragging your feet around this, but this is a real scenario. We actually tested this. It actually works. This is not the time to wait 90 days for disclosure. You need to release a patch now. And again, silence. So we followed up a couple of days later and asked, what was going on? Why aren't you moving? And they said, look, I'll be completely honest with you. We know we're vulnerable. We ran your payload. It works. We are vulnerable. But getting a patch through the QA cycle, through the development cycle, everything else, takes a lot of time. We can't just patch and release a hotfix for this, which was a bit weird, in my opinion, because I think there are ways to do a hotfix if needed. But for them, it was like never unheard of. They can't do a hotfix. So it took them over, I think it was almost 2 weeks in the end, to release some sort of patch for the first type of issues that Log4j had. Okay. So to wrap up a bit about the timeline, on Friday, we had a coinminer turned into exploit around the world. Saturday morning, we already filed the first report with IOCs to our customers and to the community. It was adopted by the DHS, the American DHS, and was sent to other law enforcement and certs around the world. On Sunday, we released the first version of our tool. Tuesday, the version with the LDAP. By the end of the week, we had already lists of servers with known vulnerable, that they were known to be vulnerable to Log4j, all of them waiting to be fixed. So a question that we got asked was, why did we go open source with this tool? So for us, it was a really easy decision to make. We are not a software house. We don't make money out of building software and sending people licenses to use our software. That's not the way that we work. And we saw that basically where everything was on fire, and everybody was screaming for some sort of solution. So the decision for us to say, okay, we have a tool which is better than what we saw previously, and it has the following advantages, was easy to make. It has disadvantages. It takes time. It might not be easy to use to someone not used to the command line. I don't know. But in the bottom line, it works. You can use it. And it's open source. I'm not going to charge you for it in the middle of a crisis. It's not something that we believe in. And we also kind of counted on the community to provide us back with feedback. You have a bug, fix it. You have a better way to improve this, do that. So we could do those iterations, and by those iterations, we'll also help our customers, but the community at large. So that kind of explains why did we even go the open source route. I want to take a moment and talk about some of the more ugly stuff that happened during that time. So I don't know how many of you were aware, but there was a lot of hate going on in online communities. I'm talking about Twitter, Facebook, LinkedIn, all of those social communities. People were really, really riling up against the Log4j team. They ruined our Christmas. Why the hell is my logging library doing external calls? Why can they patch their work already, do it once and solve the problem for all eternity? What kind of programmer wrote this code is crap, etc. And the fact that they issued a fix as fast as they could, and then someone else came up with a new way to exploit it, and then they released a fix 2 days later again, also gave rise to a lot of hate speech, because people were working through Christmas, they applied those patches, it was very complex to apply those patches all over your system, and 2 days later you have to do it again. So there was a lot of, I don't know, fight or disgruntled users of that library in the community saying, why can't you just do your jobs already? So I want to highlight that it was not their jobs. The Log4j team, for whoever tried to find out what they're doing, they're about 3 to 4 guys, okay, sitting in the US. They have day jobs. They are maintaining this library for the past 10 plus years. They don't get paid. It's not what they do in their day-to-day lives. They wrote this library a long time ago. Actually, someone else wrote the library a long time ago. And they came in as open source maintainers to keep it up and running, keep all of the code happening, and etc. And on top of that, I want to say something else about features. The fact that the logging library is doing that enrichment operation, those enrichment operations, it doesn't come out of thin air. Somebody is using those operations. A feature has been requested, a feature has been implemented and tested. So it might have a security vulnerability, but the bottom line of that is that somebody wanted that feature. If you're going to block that feature out of the blue, some systems are going to break. It's not a straightforward decision to say, let's block everything. You need to understand where it's being used and how. The bottom line was that it really got ugly. It got ugly to the point that people were disheartened at what was happening. I debated with myself if I should share those screenshots or should not share those screenshots. I decided against it. I don't think that it provides any value to show people acting crap. However, I say that it's wrong. We decided to take a stand and actually put our money where our mouth is. Thank you. And we reached out to the developers and said, look, we know you're working hard. We know that you are spitting blood, sweat, and tears over doing this, over your own personal lives, over your own personal Christmas, while everybody else is shouting at you. And we reached out to them and saying, we want to donate money to the project, to you guys, to offer some compensation to what you've been doing. We understand how hard it is. And we also had another objective. We hoped that some other companies bigger than us, much bigger than us, will, come to the flag and say, this is wrong. Open source maintainers should not be put front and center and to blame when some security incident happens. They should be supported. They should be lifted when it happens. We failed. Nobody gave a crap. That's pretty sad. We did try, and when we talked to them, they told us that in the past years, they received in total a couple $100. If you're aware, in GitHub, there's a like donate to the maintainers thing that you can donate like $15 or $10 or something like that to buy them a cup of coffee. So over all of the years, for all maintainers, they reached like a couple $100. So I want you to think about that when we tried to reach out to them and saying, we want to donate to you, they didn't know what to do. It never happened before. Nobody gave them money before. Nobody supported them before. Now, think about this when you think about how prolific was the Log4j library. How many appliances were affected by this open source project? How much value in engineering days, engineering hours of people going to try to fix this and solve this went into it, but not one of those companies stepped up and say, look, I understand you're working very hard. Here's $10,000 to appreciate your effort. Here's $100,000. You know what? Don't donate money. It's complicated. Here are 3 engineers for 2 weeks to help you solve these problems. Not one of those companies got up to do it. And that's pretty sad, and that is pretty recurring in open source software. Everybody is very happy to take that code into their systems, but when they discover a bug, they fix it internally. They don't push it upstream. Where they have security issues, they go and complain to the maintainers, but they don't offer support. Think about that for your own companies, where you work at, whenever you're using open source. How are you dealing with open source internally? So with that digression, I want to go back into how to handle unknown incidents like Log4j that just spring at you out of the blue, and you don't really have a playbook to what are you going to do with there's a supply chain vulnerability in one of your software libraries. So I do hope you know this quote, because I have no intention to reading it out to you. That's Donald Rumsfeld getting old and dizzy around what's known, unknown, 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 and known unknowns. But the basic thing here is that things would happen where you have no previous knowledge that it's going to happen. It doesn't matter if it's a 0 day or if it's a vulnerability, something you never considered before. Some surprise is going to happen, and you need to be prepared for it. So how can you be prepared for something that you don't know is going to happen? Well, the fact that it's going to happen gives you some edge. Like most attackers like to do, you can do living off the land. You already have control of your systems. You already have your own mechanisms to explore the system, collect data from the system, distribute patches to the system. You already have a lot of tools in your tool chest to try to attack these types of problems. Get to know your tool sets well, and if you are missing something, bridge that gap ahead of time. You might not know what the next incident is going to be, but you can prepare your infrastructure to deal with it. So I'll give an example of how we approach this. Think about the problem that I described earlier. Find out all of the different code running a vulnerable Log4j library. That's a big problem to solve. You don't have S-bombs, you don't know how to do it. But from an incident response perspective, let me rephrase the question. Find all processes in memory that fit the Java footprint that have a dependency on another memory object that is the Log4j library that has another fingerprint matches a specific version. Do you know of any tools that can do that? Well, we have plenty of tools that can do memory forensics. We can also run those tools at scale. We know how to do memory forensic collections from hundreds of thousands of machines over the network, searching for specific patterns. Hopefully, most of you are aware of what Sigma rules are or Yara rules are and how to run these tools. And if not, your IR team are absolutely certain to know how to do that. By rephrasing the question in a sense that makes, I have an indicator of compromise, I want to search my entire network for that indicator of compromise, you switched the question around into something that is much easier to solve, and you probably already have the tool sets to do that. You have EDRs installed in your machines, you have patch management installed in your machines, you can probably run those tools at scale without additional effort. So, what worked for us and can probably help you out? The biggest benefit that I can point out for our customers was pre-integration. Unlike a lot of other incident companies, we don't come in when somebody blows the whistle. We pre-integrate with the customer. We have a year-long relationship with them. We try to help them out in different areas of security along the year for 2 major things. One, I want to be able to collect information from the network independently of IT and security. The thing that I care about, for example, DC logs, I keep for 1 year back. Most DC servers are configured to keep the logs for 2 days. So I have a different viewpoint in what's important for me as an IR to keep. The second thing is, once I'm already integrated with a customer, we already know the people in IT, we know who holds the password to what system, we know the layout of the network, we know the segmentation, we have the credentials to access what's needed, we already have the legal permission to do what's needed to be done. So if an incident happens and you need to act quickly, your IR team can help you by actually having all of that infrastructure ahead of time already ready in your organization. And if you don't, then think about doing this, because this will save you days of labor before you even start working on the incident. And if you can nip it in the bud, everyone will be much happier. The second thing is that you don't have to invent everything. You don't need to write your own code to solve a problem. Most probably, someone else already wrote that feature, and you can just make use of it. So if you have EDRs deployed in your organization, most EDRs today already have capabilities built for IR teams or for remote capabilities that allow them to scan memory or to look for artifacts on disk. For example, look for file names that are called Log4J lib v01. So you can scan the entire file system of your entire organization. It might take a couple of hours, but it will give you answers much faster with tools that you already possess. Whenever you're doing something like that, think about sharing back to the community. So it might be a hurdle for some companies sharing IP, going open source. It might be a headache to support that. I was previously a manager at Cisco and a manager at Intel, and at both enterprises I had to push back against legal whenever I wanted to do an open source contribution. You know, you have to protect the company's IP, you have to not to take on liability. But you know, if you're, let's say, you have perseverance, you can walk through all of that legal matter and find solutions. So I think it's worth the effort. And before I wrap up, how would you help your IR team? What would be very beneficial whenever you have an incident and you need to help your IR team? Whatever you do, keep more logs. If you think you have enough logs right now, that's fine, double it. If you're not sure, triple it. The reason for that is that when we come into an organization and we don't have previous integration with them, we haven't collected data from them, we start the clock at whatever time we started. Now we try to look back in time, and that the viewpoint is limited by how many logs you have. I don't have a problem to ingest hundreds of gigabytes of logs from an organization. This is a scanning problem for my backend. That's not a problem. The problem is that most organizations don't have hundreds of gigabytes to give me. So if there is an incident and your VPN access point only keeps logs for the last 3 days of whoever logged in through your VPN and the attacker logged in last time 5 days ago, I don't really have a way to deal with that. So I'll put some monitoring in it and wait for the attacker to connect again. That's not very healthy. But if I was already there collecting those logs, I can just look back at my Splunk or my ELK and find those indicators and build the entire map much faster, and by the way, much more in an automatic manner, and get those results and understand what exactly happened. So keep those logs. The second thing is, if you don't have an EDR, get one now. If you have an EDR, learn how to use it. Okay? For, I don't know, 90% plus of organizations that we reach into, they don't know how to work their EDR. I'll give a real-life example. We got into an organization. They said, we know we have an attack in the system. We had some IOCs on the SIM. We know it's been doing lateral movement. Okay, question number one, do you have an EDR? Yes, we have CrowdStrike. We said, awesome, CrowdStrike usually does the job. We'll have everything. We go into CrowdStrike, and you know, it's a Christmas tree. Everything is lit up. It's red. It's flashing. So, okay, so EDR is working. It detected everything. But nobody configured the egress email address, so it wasn't sending alerts to anyone. So you have a $100,000 piece of machinery running on your network, doing its job correctly, and nobody knows. So if you have an EDR, test it, learn to use it. Make sure that you get those emails, those alerts, and when an incident comes, you'll be much more prepared to handle it. Thank you. And lastly, have a plan. So a plan doesn't have to be something very complicated, but it must have the first section, who to contact, who's responsible for what, phone numbers. I spend a lot of time, an insurmountable amount of time, coming into a new organization, trying to find out who has the password for this IT system, Who can create a user for the IR team for that system? And usually not the same person, and usually is not working in the same time zone. And if we had that contact page ahead of time, we could shave off 8 to 24 hours of the initial response time. That's part of why doing pre-integration is so important. You already know Joe. Joe can open your account. He can move from dormant to active fast. If you don't know Joe, or even the people you're talking to don't know Joe, and you have to go through 3 different hoops in the organization to find out who actually knows Joe, do that ahead of time. You will be able to resolve incidents so much faster. So, to summarize, and in the immortal words of Douglas Adams, don't panic. You will panic, but don't panic. Talk to your IR team, even if it's not a cyber-related incident. Most probably, your IR team, by being incident responders, have a different way of looking at problems. They will think more like attackers are thinking about those problems, and they probably have either access or knowledge of different tool sets than what you're aware of. Talk to them. They might have a different viewpoint that can save you a lot of time and solve problems at scale. That's what IR does, solving these types of problems at scale. Most toolings don't have a white label on them used in a tech only. You can use tools for whatever purpose you find useful to use them for. And you can utilize them for other things as well. Think about how you do patch management. Deploying scripts over your entire organization can be used for other things except patching. Whatever exercises you're doing to prepare for the unknown, or what kind of access criteria you have for preparing for an unknown, it's better to have them ahead of time than trying to make shift of what you can during an incident. So even if only thing that you have in your IR plan is the phone number of the IR company and the contact page, your internal contact page of who is responsible for what, you are already 50% there. So it's better than nothing. As I said previously, and I will re-emphasize, have good logs. And good logs usually mean don't keep logs on the machine themselves. Ship all of those logs to some remote repository. Can be in the cloud, can be local, but somewhere that is not stored on the specific machine. For a very simple reason. If an attacker has access to the machine, doing something interesting enough that it would be logged by the machine, the attacker can also delete the logs on the machine and remove traces of whatever he's been doing there. So by shipping those logs to a remote repository, some write-only database or something like that, you negate the attacker's possibility of removing traces of what he's done. Another thing that happens in a lot of organizations is know your assets. Again, real-world example, we went into a large-scale organization, big enterprise organization. They were already 10 days into the incident, and we spent like 2.5 days investigating their AWS environment. It was a large AWS environment. 2.5 days into the process, they said, oh, no, you know, we have another Amazon account we forgot to tell you about, and it had double the number of assets than everything that we explored so far. So restarting the investigation with double the amount of assets that we are trying to cover is painful. But you can save that ahead of time if you have some sort of asset management. I can recommend some products if you want. If you care enough and want to explore the tool, if it's helpful for you, feel free. It's open source. Go ahead. And with that, any questions? Thank you.
Sensei Guy, I've got to say, thank you for your expertise in the unknown knowns, where those knowns might even just be as simple as an Nmap scan and exercising whatever tooling you've got regularly. Question for you though.
Yeah.
The root cause seems to be the original work not being mirrored correctly by corporates. I've got one in mind, but I won't mention them. And specifically, when Stallman recoded Kerberos, took it home, when everyone said, oh great, we can do AD, and failed to put the 1/3 that closed that loop, create that delay. Do we need a new class of defense around our Active Directory in the light of Log4j?
Good question. The bottom line was that Active Directories were not usually directly manipulated by Log4j for most instances that we've seen. However, once you have remote code execution on some piece inside the network, you can do lateral movement. And what we've seen was that a lot of time the entry point was Log4j, But other than an entry point, it wasn't used to anything else, because usually the machine that the log historian or the log ingester, whatever, the machine that does that scale bulk manipulation of logs was not an interesting machine in and by itself, but it's a foothold inside the network where you can span out to do other things. So we did see network scans run from those machines. We saw hops to other machines, like if there are shared credentials, etc. So usually it's just a point of entry. Other questions, please?
Thanks for that, very interesting. I'd like to take you up on your offer of assistance with regards asset discovery. We have a problem with regards proliferation of cloud assets across insert name of cloud service provider here. Where would we start?
Okay, so that problem is actually, as I see it, broken down into two different areas. I'll first start with a caveat. As a company, we are not resellers for anyone, so we try to keep ourselves unbiased. We did find two specific products to be very, very useful. The first one is Axonius. So if you're aware of it, if not, I can connect you. It's a very good asset management program. It does its own discovery. It can do amazing things for large-scale networks. And for us, as IR, people coming in, trying to understand what you actually have, it's a boon. It's something amazing to work with because we have extremely good visibility into your asset inventory. The other thing is a company called Rumble, which was recently rebranded as Run0. They do a kind of network discovery, network-based discovery. So they will scan the network repeatedly to try to find new assets. Different techniques, bottom line, they do the same thing. They try to create a list or an inventory of all of your assets. That includes cloud, on-premise, multi-cloud, hybrids, etc. Oh, catch me later, I'll give you more details. Yeah?
Did they get Log4j to a point where it was still doing the enrichment, but it was not vulnerable? And if they did, could your tool tell the difference? You know, this Log4j has reached back to me, but it's okay because that one's been patched.
So as far as I'm aware, yes and no, which is the best answer. What they've done is that first they added a flag, or actually they exposed an existing flag saying turn off all remote discovery. So that was like the first type of mitigation was don't allow the Log4j to make any outside calls. But that broke other things. So they finessed it to don't do any kind of remote outside of my scope of IP addresses calls, but keep it in the internal network kind of thing. That has its own benefits and on issues as well, because it might give you some sort of limitation into what kind of payloads you can execute, but it doesn't actually stop it because you can circumvent it in other ways. The bottom line is that there's no bulletproof solution. It's like another added layer of security. The best thing that you can do if you actually own the code, that if you don't use remote, remote enrichment, just turn off the flag. You'll be perfectly safe. If you do need those remote enrichments, talking to LDAP, doing database lookups, whatever, then you need to think very carefully, how would you secure this against something that's basically an input controlled by an attacker?
Thanks.
Thank you very much. What is your approach to scan your application assets in terms of Log4j? So let's say you have hundreds of Java applications in your infrastructure. How would you scan that? And
do you mean in the situation where you own the code or where you need to scan a black box network?
Yes, you own the code, yes.
Okay, if you own the code, I think the best tool that I'm aware of right now is Snyk, S-N-Y-K. They do an amazing job of doing dependency checks and doing static analysis of your code, trying to find out what kind of vulnerabilities you're importing inside your dependency chain. So they're a very good tool for that. There are other tools similar to them. Just look at whatever competitor Snyk in Google. You'll find others. The bottom line here is usually that you take on a lot of responsibility when you print import in your code, and usually you don't know what kind of issues you're bringing with it. That kind of problem is not only security related. A lot of times companies will import license issues and legal issues into their code base, but by not scanning for what kind of libraries the developers are ingesting into their code. So it's not just a cyber issue. There are other types of products that try to give you an overview of what kind of licensing chaining you're doing inside your code, which is a very similar problem to that dependency issue. That answers the question? Anyone else?
Any more?
So a last word from me. I'll be hanging out. If anybody wants to chat with me, I'll be out available for more questions. Thank you very much.
Thank you. Thank you very much, Guy.